Welcome to AminAcademy.com. In strength of materials, let us discuss about power transmitted by a shaft and some solving problem. Look at here. We know that the main purpose of shaft is to transmit power from one shaft to another in factories and workshops. Now consider a rotating shaft which transmits power from one of its end to another. Let n equal number of revolution of shaft in rpm, revolution per minute. Let t equal average torque, and let it be in kilo newton meter. Work done per minute, equal force into distance. Force into distance is work, that is 2 pi n into t, that is t into 2 pi n, which is equal 2 pi nt, work done per minute. Therefore, work done per second is 2 pi nt over 60, because it's work done per minute per second is divided by 60. Work done per minute, work done by second is in kilonewton meter. Now, work done per second is here. Therefore, power, actually work done per second is a power which is equal 2 pi nt over 60 kilowatt. Now we got the relation, that is power equal to 2 pi nt by 60 kilowatts. Now let us do an example problem. A circular shaft of 70 mm diameter is running at 180 rpm. If the shear stress is not to exceed 50 MPa, that is megapascal, find the power which can be transmitted by the shaft. Here the given things: diameter 70 mm and toe, shear stress is 1, that is shear stress is 50 MPa, which is equal 50 Newton per mm square. Then RPM n equal 180 RPM. First we find the torque transmitted by the shaft equal y by 16 into y by 16 into toe is 50 and dq, that is 70 q, which equal 3.3657 10 power 6 Newton mm, which is equal Newton mm that is 10 power 6 is for 10 power 3 is kilonewton, another 3 is for meter. So which gives therefore torque equal 3.3657 kilonewton meter. This kilonewton meter. Now power per mile 2 pi nt by 60, which is equal to pi n is, which rpm is 180 into torque is 3.3657 over 60 equal gives 63.4 kilowatt. This much power can transmitted by this shaft safely. One more question. A halo shaft is to be transmit 250 kilowatt at 85 rpm. If the shear stress is not to exceed 80 MPa and internal diameter is 0.6 times the external diameter, find the diameters of the shaft. Here, the halo shaft, the power equal to 250 kilowatt and is 85 rpm. Toe shear stress equal 80 MPa equal to 80 MPa. Your Newton per mm square. MPa is equal to 80 Newton per mm square. Now we have also d over d, ratio of small dia to bigger dia is 0.6 given. Now from this d equals 0.6 d. Now first we'll find torque. Torque is pi by 16 formula, pi by 16 into toe is 80 into halo shaft, that is d power 4 minus d power 4 over d. We will put the values 5 by 16 5 by 16 into 80. D is d power 4 minus here small d is 0.6 times the capital D power 4 over d. Now further 5 by 16 into 80 d power 4. Here 0.6 d power 4, d power 4 minus 0.6 d power 4 over d gives which is equal 0.8704 d cube. That means 0.6 power 4 into d, that is 1 minus 0.6 power 4. Then after simplifying we will get 0.8704 d cube. Then therefore after simplifying torque is 15.7 d cube Newton Newton mm, which is converted to Newton meter square. Newton meter is 15.7 d cube into 10 power minus 6 Newton meter. This is a kilonewton per meter. Uh, 15.7 d cube into 10 power minus 6 kilonewton meter. Here the power is 250 kilowatt. So power equal to 2 pi nt by 60. Power is in kilowatt, that is 250 equal 2 pi. N is 85 and torque is 15.7 d cube into 10 power minus 6. That is 10 power minus 6 is used, that is here, because we are converting this Newton mm square into kilonewton, that is here. Kilonewton meter. This is Newton per mm, that gives kilonewton per kilonewton meter. So we are using as it is here over 60, then this equated to 250. By cross multiplying, we have d cube equal to 250 into 60 over 2 pi into 85 into 15.7. 15.7 cube, because it is 15.7 whole cube. Then, so, which is equal 0.007261 72613. Now taking cubic root, d equal cubic root of, which is given as therefore by using d is cubic root taken out is 0.1936 meter and d equal 0.6 into 1936, which is equal 0.1162. Therefore d equal, and converted in mm, 193.6 mm, that is meter is converted to mm, and small d equal 116.2 mm. We have done. Please subscribe our YouTube channel.